Group 16 elements. The group 16 elements include oxygen, sulfur, selenium, tellurium, and polonium are called chalcogen. The abundance of the elements are shown here. Oxygen has the highest abundance over any other element on Earth. From the table, we may notice that there are generally 6 valence electrons for each element. The covalent radius increases with the atomic number, so do the ionic radii if available. Ionic radii are much greater than the covalent radii. The electronegativity values of oxygen is the highest. There is no evidence that a group 16 compound contain monatomic cations. The listed first ionization energy is to show the expected decrease down the group. The first electron affinity are all negative for the group elements. The positive value of the second electron affinity show that you have to put in energy to perform this change. The second electron affinity of oxygen is particularly high because the electron is being forced into a small, very electron-dense space. The size of a sulfur atom is larger than that of an oxygen atom. The second electron affinity of sulfur is less than that of oxygen. Usually, the second electron affinity for all the elements are positive because of repulsion. The atomization energy decreases down the group indicates the interaction between atoms decreases. Dioxygen, O2, is a colorless gas but condensed to a pale blue liquid or solid. In all phases, it's paramagnetic. O2 should be a powerful oxidizing agent, but the kinetic barrier is often high. Ozone is much more reactive than O2. For examples, ozone reacts with sulfur, iodide, even lead sulfide. Allotropes of sulfur include cyclic S6, S7, and others. In most of these, the SS bond distance are around 206 picometers, indicative of single bond character. Sulfur is a reactive element. It burns in air with a blue flame to give sulfur dioxide and reacts with fluorine, chlorine, and bromine to form halides. The most known hydride of sulfur is hydrogen sulfide. Hydrogen sulfide is actually more toxic than HCN. Another hydride of sulfur is polysulfine. For disulfine has the structure resembles hydrogen peroxide. Many metal sulfide selenides are semiconductors with special photoelectrical properties. Chalcogens react with halogen yield halides and oxohalides if oxide is used. Sulfur dioxide has a V-shaped molecular structure. See the resonance structure. Reacts with oxygen, fluorine, and chlorine. Also reacts with heavier alkali metal, fluoride, to give metal fluorosulfide. Sulfur trioxide has a triangle structure. It's very reactive with many compounds. Sulfurous acids dimerize to form disulfurous acid. However, neither sulfurous acid nor disulfurous acid has been isolated experimentally. We just obtain the solid salts containing sulfide ions and metabisulfide ions. Dithionic acid is another sulfur oxo acid that is only known in aqueous solution. There are some generalities for the oxo acids of group 16 elements. Oxo acid chemistry of sulfur resembles the complicated system of phosphorus. There are structural analogies between sulfates and phosphates. Redox processes involving sulfur oxyanions are often slow. Selenium and tellurium have a relatively simple oxo acid chemistry.